come back to the board. Do you see the board again? Entonces, this is the answer for P of 7. You plug it into the Q and final. So we have two steps. We have two functions. And the order is extremely important. It's not crazy. It's this order. The letter be close to the argument, que is 7 in this case, is my innermost function, and after my second function is G. Okay, let's do it. Okay, if you want, you copy separately, P and 7. Okay, you copy that part. And P and 7, you take the equation of P, que is x squared plus 6, so you take 7 squared plus 6, no? 7 squared is 49, plus 6 is 55. 55. Entonces, basic, so far we have Q evaluating 55, no? I did that part. I did here. And Q55 is Q, the expression for the Q is the square root. 55 plus 9 is 64. And the square root of 64 is 8. And the answer is 8. Q composition P in this order, evaluating 7 is 8. Okay. Let me try to understand this. Okay, the composition function, we can interpretation. This is one, memory device to understand this. So a function, you consider it like a box. It's a black box. In the black box, we have input and output. And in this chain, my first function is P of X. Because according to this, no? And the element in the domain, you get inside the first block, the first box is X equals 7. I did that, and the answer was 55. And 55 get inside the second block. Okay, the second block or box is Q, sorry. And Q is square root something, and the answer is 8. This is the sequence. Okay, maybe in this case we have two functions, but in general we have 2, 3, 4, 5. It's a chain of the function. Do you understand the idea, or is confusing? Come on, opinion. Confusing, clear, confusing, clear. We have two options, clear or confusing. Zoom up or zoom down. Like that, boom, boom, or down. If P is 8, Q is 55. But actually, we need no separately answer. We need the final answer after the total change. The total change, sorry, no change. Okay, this is the intermediate value. This is the intermediate value. I don't care. The value I care is this. Okay? Let's do it in the second. The second is similar. This is equivalent. Si you don't feel comfortable with this symbol, okay, Q composition P. Q composition P is A. Yeah. You're right. Okay. The final answer is, look. Let me see. This answer is Q composition P evaluate at 7. This is the answer. Now, in this case, P composition Q, and I switch it, the order. So I switch it the order, so you evaluate 7 and Q first. So this is equivalent to say P parenthesis Q evaluate 7. Q is a square root. Let me write here. Q evaluating 7 is the square root 7 plus 9. 7 plus 9 is 16, and the square root 16 is 4. This is the intermediate value, okay? And you evaluate 4 into the P function. Okay, P is x squared plus 6 is 4 squared plus 6. 4 squared is 16 plus 6 is 22. And this answer is the result of P composition Q evaluation. In the story. It's important to understand that the order is extremely important. In general, please go ahead. Question.
No, can you move the mouse? It's blocking.
I don't understand. I don't understand. Your microphone is weird. Come on, try to speak slow down, slowly, and clear. Come on. Repeat the question, please. Or use in the chat. Move with the mouse. Okay, move with the mouse. Move with the mouse. The mouse like that to see completely the picture. So in this case, suppose the sketch of the block. I don't know if you like or you don't like this idea. You have the first function as Q and the second as P. And the initial value you plug in is 7. It's the same in both cases. But the answer, the output value is 4. 4. Okay, this is the Y value with respect Q, but it's the X value with respect P, because now this is the domain. This 4 is domain of P. And the answer is 22. Another kind of problem, this is the most popular. So you have numerical value, you have two functions, and you try to understand the order of evaluate the function. But another question you see about the composite function in the homework is when you have the famous arrow diagram like that. This is a little bit more complicated. I have a question. Come on, Launa. Using the chat or activate the microphone and try to speak. We have two answers or one. No, we have two answers because you have two questions. So the question contains two parts. It's computed, o sea, the test no, pero in this problem that I create for you, you say compute this part and compute that part. And this is the answer for the first part, and this is the answer for the second part. Two questions, two answers. Yeah. Is your question, Laura? Okay, let's focus on this example. Okay, is this ellipse or this oval represent domain of the one hypothetical function I call f, and this is the range of the y. Remember, domain is the set of the x value. So hypothetically, you suppose que f1, f3, f4, f5. This is given. This information is given. And this is x. X equal 1, x equal 3, and so on. No? X equal 4, and x equal 5. Entonces, you stay as the association function when the another value, que es the y, also is 3 value. 0, 6, 0, 0, 0. 6 and 9. Okay, this is 0. Let me erase again and put 0. This is 0. And the association is given also. I don't know exactly what is that, but 1 associated with the 6, 3 associated with the 9, and 4 associated with the 6 again. And 5 associated with the 0. Okay. This is my first function. Okay, I call f. This is f. By the way, is a function or no? Satisfy the condition for the function or no? Is a function or no? Yes or no? Let me see. Answer. Yes, it is.
Yeah.
Remember, according to the definition for the function, is 1-to-1 or many-to-1. The only case not acceptable is one too many. But in this case, it's good. It's perfect. Okay, super. We have another function. Ahí. I click in the wrong place. Okay. Do you see the board now? Good. Let's continue. We have another function because remember composition. We have another function. We have another function. This is the function G. This is domain of G. And this is the range of G. And the element inside the domain of G is 3 values, 4, 6, and 9. And associated with the 2 values in the range, 2 and 6. Okay, entonces 4 es asociado with the 6. 6 is associated with the 2. And 9 is associated also with the 2. And this is the G function, again, by the same reason. Entonces, my goal is, okay, what's the question? The question is determine. Okay, the question is determine domain of G composition F. And the second question, 2 questions, 1, 2, 2 answers with sped range of the same G composition. The domain and range of the composition. But this is important, the order. F is the first function, the innermost. Okay? Now, when you set out relationship, look, let me try to make another sketch, more simplification about this set. For example, I have one set here. I have another set here in the middle. I have another set here. The most important is this set. This set is intermediate inside the chain because you need to state the chain from the domain of F to the range of G. But this set is formed by the intersection between these sets. They are common elements. See, there are no common element. We cannot state one change. For example, let me explain. 5. I pick 5. 5 is associated with the 0. But 0 have no value here. So the chain is broken. Suppose 1. 1 is associated with the 6. 6 we have here, nice, and 6 is associated with the 2. But this intermediate block is formed by the intersection range of F intersection. This symbol is an domain of G. I need to find the common element in between this set and this set. It's obvious it's 6 and 9 only. 6 and 9. 6 and 9, 6 and 9, 4 no, it's common, 0 is not common. Okay, and this is the set intermediate working like a range of the F in the composition or domain of G in the composition. So when I write the same thing, 1 is associated with the 6, and 3 is associated with the 9, nice. And 4 is associated with the 6 again, no? Look at that. 4 is 6. And 5 is completely out because 5 is associated with the 0. So I can mentally eliminate this line. This line is not important in the composition. Okay. Okay. Let me continue. In the second set, when we have 2 and 6, but remember we have only 6 and 9. So 6 is associated with the 2. 2. 6 is associated with the 2. And 9 is associated also with the 2. And this 6 do not participate in the game. It's logical because 4, I completely delete this connection. So I can see now that this diagram corresponds in the big picture like one initial set and one final set. Guess this. We have 1, 2, 3, 1, 3, 4, sorry, and 2 here only. So you see the trajectory, 1 associated with the 6 and C associated with the 2. But directly in one shot, 1 is associated with the 2. 3 is associated with the 9. Finally, is associated with the 2 again. And 4 is associated with the 6. Definitely is associated with the 2 again. So you are ready to answer that question. What is the domain? Domain is 1, 3, 4 of the composition. What is the range? Just 2. End the story. Any question? What part is confusing? Super easy. Super straightforward. The most important is you combine 2 functions. But it's a special combination. Remember, we studied the elementary combination using addition, subtraction, multiplication, and division. This is a very, very common combination for the function. But another combination is composition. Another combination is composition. Another question. Okay, you can see. Do you understand, guys? Yes or no? Come on. I want to see your face. Not your face, your comment. Professor, it's clear. No, I got it. Okay. Jordan say, it's okay. Zoom up. Another opinion, coño. Okay, yes. Double Y. Yes, with double Y. That means it's super yes, no? Launa, okay, you are a smart girl. You are doing everything okay. She's fantastic. Get 100 points, do the homework. Okay, super. Okay, one more example to illustrate a little bit. I know that this is a little bit abstract. Okay, this is the part of the algebra that is a little bit abstract. It's not like a elementary algebra, and when you solve the equation, this is a mechanical job. This is a little bit abstract. This is the classical problem of the Euclid algebra. Euclid algebra is a little bit abstract. Okay, suppose we have one function. Again, we practice a little bit about composition. But another point of view. Suppose we have capital H. Is square root 5 minus 4x. Entonces, they want to know can you decompose this capital H function in 2 functions? Okay, I suppose que f composition G of x is equal capital H of x. So decompose. There are many ways to decompose this function. Well, in my opinion, the most probably way is que you suppose, remember, you have 2 blocks. According to this notation, the first block is G. And the second is F. Entonces, inside, always we have element in the domain que es X, this X. Entonces, the function G processing the information like that. Look, I suppose, this is supposition. Que G of X is 5 minus 4x. Okay? This is the expression that represents that function. Entonces, outside, in the output of this, I have y equal 5 minus 4x. And f is the next. So I define, using my imagination, que es square root x. Pero this x is not this x. It's the new x that we have here. Because now this element represents the domain of f. Now in the output we have square root of this is 5 minus 4x. Okay, see, it's confusing for you. We can change a little bit this variable. Entonces normally mathematical you using u is the intermediate variable, no? Entonces this is not y, it's a u, and it's a u, and it's a radical u. And what the hell is u? U is 5 minus 4x. It's another point. It doesn't matter. Okay, this is the only possibility. No, of course, no. Another student said, no, professor, no, I disagree with this idea. I suppose que G function is just 4x. Que es that part. Or minus 4x. Then f function is square root of the rest. And the rest is 5 minus u. And what the hell is u? It's a u. Plus, because double minus become positive. So one block, initial block, G, okay, the only mathematical processing is x, and give me u, and this is minus 4x. And we have another block, que es f, que es square root 5 plus u. And u is minus 4x. You replace this and this, we get exactly the same original. There are several combinations. Another student say, no. I don't want this. We have another. There are no infinity possibilities. But this is basically the idea. It's decomposition. This is important, guys. The student can need to take calculus. You need to understand composition because they are in calculus. Some operator can working a little bit different in composition function. Okay? Any question? So the topic composition is understandable. I suppose that I retake this in the review packet, no? In the review packet, we discussing everything at the beginning. But quickly, I go fast, and you can ask me any question. Super. We are the best in Miami-Dade College or no? We are the worst. Or the best? Okay. Another topic. Yes, we are. Okay, another topic I want to discuss and get super easy is yes, we are. Okay. Es function que es even. Functions. We have some functions. Que es even function or odd function or neither. I promise that we're using this idea and when you want to investigate in the function, you want to investigate symmetry. I want to explain it up. Because I want to explain algebraic way to prove that. Here I want to explain the geometric interpretation of this. Okay? In my opinion, is super important. Symmetry. Suppose that we have even function. Even function is a function. And when you perform reflection, remember we have two kinds of reflection. Reflection about y-axis is one possibility. And we have another reflection that is about x-axis. Or about the origin, more properly. Origin. Entonces, to perform reflection, you remember that the formula for the reflection and the transformation is you replace x for negative x. This action immediately reflect the function. with respect to the y-axis. But sometimes happen amazing suddenly that the function stay the same. Si the function have that property, it's because this function is even. Let me try to understand. Algebraically. Suppose the function f of x is given in the test is x squared plus absolute value x plus x to the fourth power. So the question say, prove algebraically if this function is even. Okay. So you are doing reflection. You replace x for negative x. So we have a negative x squared plus absolute value negative x plus negative x to the fourth power. Entonces you manipulate a little bit algebraically this expression. Yeah, I know that when you have even exponent, it's positive, no? Y actual value is also positive because actual value negative 3 is positive 3, no? So it's like that. And this is happening exactly the same, by the same reason, because it's even exponent. And when you compare now, look at that. This new expression after the reflection and the original. Wow, they are twin brothers. Stay the same. Therefore, this is even. Okay? What is the geometric interpretation of this? Let me try to explain. Okay, I just easier to say if the exponent. okay. It's the first example, no? I promise in the view pack I put it more complicated, no? But okay. She said it's logical because the exponent you use in professor is even. Even exponent, even exponent, no needed. Yes. O sea, even exponent always is even function. No, there are examples que no. Okay, but in this case, yes. Okay. Don't try to generalize everything. This is the procedure. You replace x for negative x. See, nothing happened, it's because it's even. I promise that you see another example. But this is the first example that you need to understand. But I want to explain geometric interpretation. Okay? Suppose the famous f of x equal x squared, que es de parábola, que everyone know very well que look like that. And therefore, this is the y-axis, this is the x-axis. And when you replace x for negative x, the thing we are doing is reflection. Okay, algebraic, I can see, wow, it's the same. But geometric is the same because we are doing reflection. This branch become like this branch, and this branch become the other branch. So nothing happened. Nothing happened when you are doing reflection about the y-axis and the parabola. The parabola stays the same. It's because this is even function. So we take advantage this concept to prove the even function. Entonces you say, bueno, professor, but what is the importance? What is the utilization of this idea? Okay, let me try to explain. Suppose that we have a super complicated function. So we study, I promise we study in the test 3, very, very complicated. In one moment, you need to prove the symmetry. What is important? Determine if one function is symmetry or no. Well, see, I prove somehow that the function is even. Okay, so it's the boss. Okay, see, I prove somehow that the function is even. That means that one arbitrary value of the x here give me one value of the y, and you get the point, x comma y. This segment is x, this segment is y. Si you prove that the function is even, the situation que happen is that the negative value, look, the negative value, here, the negative value of the x here, give me exactly the same segment here of the y. Therefore, the even function always look like that. I don't care what happened in the middle, but it look like that, or like that. This is the classical graphic of the even function. Symmetric with respect to the y-axis. Maybe it's, suppose another example que I put here que is using transformation. Suppose f of x equal minus x squared. Entonces we have reflection, but another kind of reflection, que es reflection about x-axis. But it's even also, right? It's even also. Look at the symmetry. It's symmetric with respect to the y-axis. Es fantastic. Entonces I promise the student can need to take trigonometric to apply this in trigonometric function and other more complicated functions throughout your life. Okay? Everyone understand very well even function? Even is clear? Even is special. And odd is also special. Odd function now. But it's another kind of special. Suppose you are doing reflection again. Reflection is replace x or negative. And suddenly happen amazing que the minus is outside. Okay? Okay. I recall quickly que even is when you are doing reflection, nothing happens. And it's que yeah, happen, pero es this minus que you put inside the parenthesis is reflected outside the parenthesis. Let me try to put example the algebra. And first of all, I want to interpretation geometrically the idea for the odd function. Suppose the function f of x, que is cubic function plus x, something like that. Okay, I have no idea. I have performed the reflection. Entonces we have x to the cubic power plus minus x. Entonces you see, wow, look at that. When the exponent is odd, it's negative. In this case, the exponent is 1 is negative. And we compare this function and this function. They are twin brothers? No, no twin brother. They are completely opposite sign? Yes, because this is plus and this is minus. So this function is odd function. Interpretation this. Suppose the classical example of the cubic function. Suppose f of x, one elementary function. Do not complicate your life. Cubic. Okay, you know the basic function look like that. It's a classical odd function. Suppose that you are doing reflection about y-axis. Then my new function is like that. Okay, that was, look, y equal x cubed. And this was y equal minus x cubed. Therefore, the reflection about the y-axis was identical to the reflection about the x-axis, because when you reflect to the x-axis like that, this curve is transformed like the blue. And when this situation happens, this is odd. Okay, and even when you are doing reflection, nothing happens. In odd, when you are doing reflection in the y and the x, it's the same thing. Entonces, one interpretation for the symmetry. Well, okay, I understand now. Look, do you prove somehow that the function is odd? I only care the positive part. Okay, suppose 1x here positive. Give me 1y positive. Supposition. And give me the point x comma 1. Because in the negative part happen exactly the same but in the opposite direction. Look, this is minus x. Remember, si es even, it's the same, pero si es odd, it's opposite direction. This negative y is the same segment, but in opposite direction. Minus x, comma, minus y. Okay, this is symmetry. This is called a symmetry with respect the origin. It's, you know, it's like if you put the segment like that, this segment is exactly in the opposite direction. This is symmetry, and the even is symmetry like that. Okay, with respect the wax. Entonces, even function and odd function are special. Different kind of special, but it's special. But we have a lot of functions que do not satisfy the condition of the even or odd. Entonces es even nor odd. And this is called even. Okay? Neither is no even nor odd. It's called neither, in my opinion, it's called ordinary. And even odd is a special, sophisticated function. Okay? Entonces I bring some example. And you let me know. What do you think about this? I have no idea, no? Suppose that two examples. Let me see, three examples. Three examples. And you let me know. So this is a typical question in the test. Proof, determine algebraically whether the given function are even, odd, or neither. Okay. Suppose the first one, g. G of x is equal x cubic plus x plus 1. Well, algebraically is doing reflection like that. Okay, I apply some algebra. I know que negative x cubed is negative x cubic without parentheses. Do you understand why? You break it down like that. Look, this negative you can interpret it like a negative 1. This is negative 1 cubic and x cubic, no? And negative 1 cubic is negative 1 and negative 1 and negative 1. 3 negative become negative 1. This is negative 1 is this invisible negative 1 que we have here. Okay? The shortcut. Si the exponent is odd, es negative. Si the exponent is even, es positive. Entonces, plus and minus negative, plus 1. And that's the crucial moment in which you compare this guy and this guy. And let me know, it's even, it's odd, or it's neither. Okay, this guy and this guy. Neither. Junior door. Say neither. Because okay. Suppose I don't have, I am lost. Okay. They are twin brothers. They are twin brothers. They are twin brothers. No, no twin brothers. No, exactly the same. Something changed. They are completely opposite sign. They are completely totally opposite sign. No. Okay. Okay. Remember the definition for the even. Even is when you are doing reflection. That's the thing we are doing always. Nothing changed. This is even. When you are doing the reflection, this reflection is equivalent to put a negative outside. This is odd. Otherwise, either. I suppose it's otherwise. Because this is negative chain, this is negative chain, but this stays the same. Okay, everyone follow me in this example, this confusing example. Tricky. Let me try another. So suppose the function h is x cubic over x squared. Come on. It's neither because, well, it's neither because the relationship is neither. Okay, do not satisfy this idea and do not satisfy this idea. Entonces, es neither, right? O sea, remember, I repeat again the idea. When you are doing the reflection, see the new function stay the same, it's exactly the same of the original. They are twin brothers. I say in the colloquial way, twin brothers, exactly the same. Entonces, even si es completely opposite sign, but in this case, not completely opposite sign, because this is plus, this is minus, okay, completely opposite sign, plus, this is minus, completely opposite sign, but this is plus and this is plus, not completely opposite sign. Neither. Catch it? Do you understand now? Jordan, it's okay? Don't be shy. Any question, you let me know. Okay, maybe my word is not the convenience word that you need to hear in your brain, no? And then I use my word, but I can't change my word to explain everything. Clear or confusing? Okay, super. Okay, what do you think about this? Well, I have no idea. I am totally lost. No idea. Lost. But I know the professor explained I need to make a reflection. When I make a reflection, I put minus x cubic. I put minus x squared plus 1. I know that when the exponent is odd, it's negative. Yeah, I know that when the exponent is even, is the same. Entonces, this is the moment to compare this and this. But be careful, because this is a fraction. And you need to know that when you have fraction, suppose fraction, 4 over 5, but minus 4, I suppose. This is equivalent to say minus 4 over 5 or 4 over negative 5. So the minus you put in the top, you put in the bottom, or more elegant, in my opinion, put in the middle, in the front. So if you put the minus in the front, this is a moment to compare this expression and this expression. They are okay. Let me repeat again the idea for the even, odd, and either. Okay. The idea is, this idea maybe help you. So, Jordan. Okay, look at that. The idea for the even is, see, I am doing that reflection and it stays the same, it's not the case. So something is changed, it's minus. But the odd is when you are doing this reflection and you see we have a minus in the front, a totally minus, entonces es obvio que es odd. The answer is odd. Do you understand or you don't understand? Or you are totally lost? One more or no? This is, in my opinion, you destroy in 1 second. One more meeting, yes, okay. Suppose p function is x to the second power over x to the fourth power plus 4. Okay. Let me do the reflection. It's minus x squared minus x to the fourth power plus 4. Entonces, this is positive. And this is also positive because both are even exponent. No? And this is a moment to compare this expression and this expression. Okay? Even, very well. Okay. Some student of the other class send me a test. Okay, I suppose that you understand very well the topic about even, odd, or neither function, no? We practice in the review back again, of course. Let me try to explain the last part. The last part is super easy. In my opinion, is the give. However, unbelievable. You don't believe. Some people fail in that. Unbelievable. This is determined when the function is another. It's another property of the function: increasing, increasing, decreasing, and constant. Okay. Let me explain the definition. Suppose if x2 is bigger than x1, and you prove somehow that y2 is greater than y1, the category of this function in this interval, of course, is increasing. Let me try to understand geometrically. xy. Suppose x1 here, suppose x2 like that. Suppose the function. This is y1, this is y2. I see the behavior that the function is increasing because the y2 is higher y1. So basically, to analyze the increasing, decreasing, or constant, you always walking from left to right in x direction, left to right. If the y go up, it's obvious it's increase. Similar situation happen. Well, similar no, completely opposite situation happen. Si es decreasing. Decreasing is que the formal definition is if I suppose that x2 is bigger than x1. This is the supposition. And this imply that y2 is smaller than y1. It's because we have a point x1 here. We have the point x2 here. Okay, suppose that x2 is always bigger than x1. However, the y no. The y happen different situation. Suppose like that. It's going down. It's going down. Therefore, decrease. Decrease. This is y1. And constant is, the same value. Constant is, suppose, again, x1, x2, in the same condition. So I suppose that x1, x2 is greater than x1. However, the y is the same. y1 is equal to y2. Let's see, it's equal, look like that. This is y1 equal to y2, and this is constant. Constant function stay the same, doesn't change, no decreasing, no increasing. And this is super easy to understand. One graph is given, suppose. Maybe a hypothetical graph. Hypothetical graph. Complicated in different intervals. Suppose something like that. Suppose suppose numerical. Suppose that this point is 2. It's 0. This continues forever. I don't know. And this continues forever. This point is 4 because this is 3. This is 4 in x value. This is 5, 6. This is 8. Entonces, determine in what interval. Entonces, to confuse you, this value, this is 4, guy, here. This is 5. This is 7. Normally, not necessarily too much information. But this point is maybe 3 in y value. This is 4 and the y value. This, I suppose, gets the same. to simplify the thing. Entonces, they want, okay, the specific question is, let me read, determine. The intervals, plural, over the function. Is decreasing, comma, increasing, and constant. Pero they want more. They want that you write the answer in interval notation. This is the universal notation. Universal way that you need to be aware in the test. Always any interval, just press it like an interval notation. Okay? Entonces, what is your call to analyze this super quickly? Bueno, you suppose que we have a roller coaster. Suppose que this is a roller coaster. Entonces the car and the roller coaster look like that. Boom, boom, boom. In this case, in what direction go? Go up or go down? Go up or go down? Go up. Remember, the x value always is coming from left to right. Then, in my opinion, the interval in which start up, okay, by the way, up is increasing or decreasing? Up is increasing or decreasing? Increasing, of course. Entonces, I suppose que from negative infinity, look, to this point, get to, I highlight this in yellow color. Okay, this is from negative infinity to 2. Es obvio que the function increase. Vamos a ponerle aquí little I, increase. Okay, after because we have several intervals, no, it's only one. Another increasing, guys. Okay, this is decreasing, no? Es obvio que this is decreasing, no? The roller coaster is going down, no? Okay, it's from 2 to 4. It's decreasing. Again, now, the roller coaster, when the cars go up, it's blue. Another increasing for 4 to 6. Entonces, union to 4 to 6. And never increasing anymore, no? Because this is constant, I suppose. That part is constant. That's the same height. And this is decreasing again. And we have another interval that is decreasing, que is from, okay. Let me highlight increasing in yellow color. This is increasing. Entonces, I call this interval, this and this together, union is increasing. And the other interval is decreasing is from 2 to 4. Let me use in blue color. Another that is decreasing is from 8 to infinity positive, because this arrow indicates us that this curve continues forever like that. So union 8 to infinity positive. This is decreasing the behavior. And constant, well, is in that part. From 6 to 7. From 6 to 7, the y value stays the same as 4, but I don't care the y value. It's from 6 to 7, no? Parenthesis 6 to 7. To 8, no? To 8. This is constant. something like that. What is the typical mistake in this question? This is super easy. This is only looking the graph and using your common sense. But what's the problem? The problem is, number one, is that the students try to mix it with the y value. And this y value is given to confuse you. Suppose it's given 2,4. Suppose that this point is 1,3. And entonces the student mix it 3, 4. No. In the interval, you express only x value. Please. When they see y value in the interval, immediately 0 for you. Number one. Number two, mistake. Some students try to enclose using the bracket the endpoint. Supposed to. No. Why no? What is the behavior in 2? In 2, what happened with the roller coaster? It's going up or it's going down? In 2? Nothing. Because it's a transition from increasing to decreasing. The behavior in 2 is, I have no idea. It's nothing. And the 2 is no inside in the increasing interval, neither in the decreasing interval. And this is the typical point. This point is a transition, is another concept, but no important in the college algebra. It's a local maximum. And this is a local minimum. Maybe you don't understand very well what is the reason it's local, but in cálculo you understand much better. Local minimum. Okay, local maximum, local minimum is the transition between increasing to decreasing, or local minimum is the transition between decreasing to increase. End of story. Any question? Any question? Any question? Entonces we spend the rest of the time start doing the review package. Let me try. May I erase the board or no? Do you copy? Wow. Okay, good. Share it here. Okay. Let me try to. Wait, where's the PDF format? This is the first page of the review book. Insert. Okay. Let me enlarge. Much better. Oh no. This is my first page of the review book. Entonces perfect matching with the thing that we study now. Is determined. Okay, let me maximize, make a zoom. Let's change that much. This is I try to do again this figure here, enlarged. And this look like parabola, no? Like that. 1 and 4. Remember, the parabola is a smooth curve. You never write a parabola like that. It's the corner, no good. And this point is 0,7. So to confuse you, you see x and y. This is x value and this is y value. And the y value do not participate in the answer. And this point is 4,0. And this point is negative 4,0. Entonces, day one, que you determine the interval in which the function is increasing, decreasing, or constant, no? Okay, entonces I use in the roller coaster, for example, I go from left to right, so I travel in the x-axis from negative infinity to positive infinity. Entonces, my roller coaster, I suppose to travel in this direction. Okay, entonces this is another confusing thing. Some students ask me, Professor, but what means this arrow? This arrow do not indicate the direction of the motion. No, this arrow, the only thing indicate that this parabola continue forever in this direction. But I have a limited space in my paper, so I indicate using this arrow. But the motion is always from left to right, on the curve, on the curve. So in that part, we travel this. And when you travel this, you go up. And when you go up, it's increasing. So this interval from negative infinity to 0 is the interval in which the function is increasing. So you're right. From negative infinity, comma 0. Of course, do not include 0 because 0 represents the local max. I don't care. This is increase. You put capital I. Yeah, everyone understand. I understand. It's increase. Now, in the second part, continue walking from left to right. We have that part. And the roller coaster is going down. Therefore, the function is decreasing. Is from 0 to positive infinity. It's decreasing. And what about constant? Never is constant. Increasing or decreasing. Constant, never. That's the answer. A1. End of story. Any question? Any question? Any question? Please help me. Are you feel strong in that part? Strong, or you are sleeping, or you are boring?
I have a question.
Please go ahead.
I thought that graph would be constant due to the fact we're only going on the x-axis and it's going in a straight line, not incorporating the y value. So.
Because the interval, okay, the convention is the interval K1 is the interval, interval. K1 is x value. Why is x value? Not because I want, no, it's the domain value. I investigate, well, that function is increasing from negative infinity to 0. I don't care the y value. I don't care if the y value is 1 million or 1 trillion, increasing. And from domain, the domain from 0 to positive infinity, it decreases, it's going down. I don't know if it's negative 1 million. I don't care. I don't care the y value. This is to confuse you. You put something here that involve 7 mistake. I don't understand this because it's x value. Because the interval can below. I don't know if it's your question or no. Please let me know.
Okay, so negative to 0 is obviously increasing, and then 4 to 0 is obviously decreasing. Okay, got it.
Okay, let's do it in the second. Let's do it in the second. Let's do it in the second. The second. Okay, I am not good in the eraser part. Let me try using this tool. It maybe sometime help me to erase everything. I don't know if it works or doesn't work. Very well. Boom. Not good. Loop. Raise the loop. No, not so. Well, maybe I have delayed. Let me try one more time. Delete. No delete. Yeah. Look at that. Boom. Oh, no, almost. Okay, good. My second graph is a little bit more complicated. Just a little bit. Because we have arrow again. You understand what means that arrow? It's going that direction approximately. Forgive me if I don't do exactly that. But this point is giving us negative 0.5 and no specification of the y value. Nice. And here is exactly the same 0.5. Okay. Okay. Now I need help. Help. In what interval that function is decreasing? Let me start decreasing first. This is my roller coaster car. This is my roller coaster car. This is my roller coaster car. Yeah. And this is three interval. Decreasing. Where is decreasing? What interval is decreasing? I need help. Come on.
Negative 0.5.
From what? From negative infinity, no? You say negative infinity? From negative infinity
To negative
comma negative 0.5. Super. And that's it? Decreasing, or I have another interval that is decreasing also? Remember, is another one. Which one? From eso, union 0.5 positive, comma, infinity. Is exactly when I put the roller coaster car in green color. This is decreasing. And increase is when I put a roller coaster car in blue color, que is from negative 0.5, comma 0.5. And constant, no. Okay? Easy. This question is easy. The only detail, and I'm warning you, I suppose that you have no problem, is because the student don't pay attention or be absent today, don't understand very well. I put the y value, so you have big mistake for the y value. Okay, let me try. Okay. Okay. No, doesn't work. A loop. Too fast. Well, okay. Okay. One more time. I try. Let me try piece by piece. Chukudu. No. Selection. Delete. Super. I need to move too fast. Selection. 1, 2, 3. Delete. Eso. I got it. And this no. This is just como eraser. Okay. So you have no problem with the decreasing problem? Let's go to the piecewise function. Piecewise function. The question number 3. What piecewise function is given? And you need to evaluate. You need to evaluate in negative 2. In negative 3. And 0. And positive 5. And positive 3. And negative 4. Okay, let me try to enlarge a little bit this document. Let me see. No rotate, enlarge. Okay. Whoa, much better to see specifically the question 3. Remember, you have 3 pieces. Let me put different color. Oh, One piece here, blue. One piece here, green. One piece here, rainbow color. And each piece corresponds with a different interval. Okay, I want to copy here. I tried to do my best in PDF, but it was not good. F of x is equal. The piecewise function is minus 3x plus 2. If x is less than negative 2. X squared plus 1. If x is in between negative 2 and positive 3. Pero no. Don't include 3. No equal. It's just 4 as a constant function. If x is greater than or equal to. You need to evaluate number 1 and negative 2. Okay, let me erase that part. And you evaluate N2. You evaluate N2. N2 no, en negative 2. En negative 2, negative 2, negative 2, at what interval belong? Belong to the first or belong to the second? Es obvio que do not belong to the second. To the second. How do you know que es to the second? How do you know? What is the glue que give me information que es to the second? Equal sign. Equal sign. Okay, look. One fantastic way to prove que this equal is the glue. This symbol indicates equal. Now, negative 2 belong to this interval. Therefore, you select this function. And you evaluate, you selection equals selection x squared plus 1. And you evaluate. Let me use in this convenient notation. You put this line for x equal minus 2. And you replace here. It's minus 2 squared plus 1. Minus 2 squared is 4 plus 1 is 5. And this is my first answer. The answer is 5. Here, 5. Okay? Let's evaluate now in 0. Okay, let's evaluate in 0. Let's evaluate in 0. 0 is the second, no? Let's move on in that direction. Okay. Negative 2, 0, 3, negative 3, 5, negative 4. 0 belong to what interval? To the first one, to the second, or to the third? To the second again. Si it's to the second again, you select exactly the same expression. But now you evaluate at x equals 0. Entonces 0 squared plus 1. 0 squared is 0, plus 1 is 1. The answer is 1. The answer is 1. Eso, bueno. Mucho bueno. Okay, now evaluate en Schwartz. Little bit complicated to handle that. Okay, look.
Hello?
It's okay. Evaluate en 3. And 3. 3 belong to this interval, belong to this interval, or belong to this interval. Number 1, number 2, number 3. Third interval. And number 3, guys, the expression is just 4. And 4 to not dependent of x. It's totally independent of x. Therefore, leave it like that. It's 4. The answer is 4. Everyone follow me so far? Wow, time is over, no? Time is over. Sorry. I don't realize. Time is over. Okay, don't worry. Relax. Everything's gonna be okay. We are doing good. Okay. We continue. Next time we have, remember, we have Thursday and Tuesday to do the review. Okay. You ask me any questions throughout the week. No? Okay, wait. Cancel. Stop sharing. You see my face? Okay, guys. Thank you. I appreciate so much your attention. Can I stay after? Yeah. Who? Jordan, huh? Okay, stay, no problem. Let me take a break, a little bit break. Drink some water and immediately in his 40. Okay. I'll right back in 2 minutes. Okay. And here, Jordan, come on.
Okay, great. Thank you. I was wondering if you wanted to just, I know you're going to review it again.
Could you put your face? Activate the camera. Maybe when I, okay, go ahead.
Okay. If you could, I know you're going to continue the review on Tuesday, but can we continue with question 3?
Okay. What question you want?
Okay, and I'm just going to tell you exactly what I got, and tell me if I'm right, if that's okay, because that's something that I had a problem with, like h of x, and this. I in the test I got with the homework in 85, but I inputted these numbers wrong. I don't know why I did it, but I just inputted them the wrong way. So if we,
okay.
I inputted the numbers the right way, but I put it in the wrong way.
Okay.
So
don't worry for this. Don't worry for this. I control this. Email me your specification. What question you put a mistake. I can go inside my platform. I go inside. I can see your mistake. See, your mistake is a stupid mistake because I fix it. Yeah, I put 100. That's it.
Okay.
Okay.
It's Alex. It's questions.
No. Email me with this information. No.
I don't remember. I can't access.
You try it. Okay.
I can't access to show you. But the numbers are correct. I just the wrong.
Understand. This situation happens frequently. It's you the first. I can, but I need precisely information. What question you don't remember?
I would if I could access the test, but I don't. I know which questions it is.
And you have no access to see. Oh, okay.
No, sir.
Okay. Just talk to me. I try to review your test number 2. Last version. You see, I try to detecting this mistake. I share to you. Okay? Yeah, I check. Don't worry. Don't worry. This is normally it happen. Okay. Every course, I need to fix it something. Any other question?
No, sir. Thank you so much.
Okay. Pleasure. See you.
Thank you, Professor.